Greetings, YouTubers. We're back in the cloud. I think I have a calendar open here somewhere. January 30th, getting close to Groundhog Day, getting close to Chinese New Year, which will be the year of the pig or swine. I like to broaden it to not just like domestic pigs, but boars, the whole family. Now, in some readings, I saw the hippopotamus listed in the porcines, but then later it was like more towards whale. If you want to figure out where does hippopotamus fit into the taxonomy of animals, feel free to leave a comment in the YouTubes down here. So what I'm just talking about today is a continuation of my recent video just a day or two ago. I was talking about Unicode and how important types are. Types, has a common meaning in everyday language in that everything has a type. A car is a type of motor vehicle. Everything is like you can sort of categorize stuff. Like we just do that naturally. We think of things in families, having family resemblance, like board games. The space of board games, think of that category. Now, what do board games all have in common? What is the essence of a board game? That may be not the right question. Family resemblance, that's where to think. In other words, there's not just one characteristic. Okay, they all have a board. But we don't, the word board game, is chess a board game? I guess, but games come in categories as well. It's often difficult to define exactly the namespace you're talking about. Anyway, in the world of education, K through 12, kindergarten through the end of high school, where I am right now in 2019, there's the math class and the math track, and that often goes through what we call delta calculus, right? Which is Leibniz, Newton. I've never run on 2.7, I don't think, this particular IDE. I've just booted up Spider. You can't see it yet. I'm going to slide it out so that you can see what I've just launched here. So this is familiar material to me, but I'm in with Anaconda, just to change the subject a bit, you can pick from different environments. So if you want to run a newer version of Python and an older version of Python, there are good reasons to want different versions of Python handy and to not have them step on each other's toes and to have their packages all get mixed up with each other's. You can get a real snake pit on your computer if you're not careful. There's a fun XKCD comic about exactly that if you want to go look or leave me comments. So I'm in the 3.7 environment, and I wanted to pull up this Unicode emoji stuff that I was doing last time a little bit more and explain why there were more than 20 emoji, because I said with confidence that we were going to be looking at the first 20 or so smiley faces, and if you were watching carefully, you can go back and look yourself. You'll see that there were 32 of them, 32 emoji. And the file I'm talking about is called Unicode. Here it is. Now, I may have messed with it a tiny bit since the last time. So what I've done here, let's make this nice and big, is I've got an actual for real Python function. Now it actually returns none. If you know about functions in Python, unless you use the keyword return with an object, it will, if you don't do this, return none. So saying return none is completely redundant. It's what you don't have to say. The one thing you don't have to say. But you might want to say it anyway. This would be exactly the same as if I took this away. Now print does not return. We have to understand the difference between return and print. Print is like sending something to the console, which is a spooky other object that you could almost say Python. It's like in another universe from Python. This is like a wormhole. Print emoji is a wormhole to a whole other window, like over here, down below. This is the REPL. This is an interactive place where we can just say 2 plus 2 or 2 add 2 and get the same answer, right? 2 actually has its own add method inside of it. In the guts of every integer, you could say, is the knowledge of how to add. And for syntactic sugar, we stick with the old math way of saying it. We don't want to have to write all these ugly underscores. They're deliberately ugly, kind of warn us away from using them in a gratuitous manner, but there they are. So I'm using, that's what we call a special name, by the way, special name. Always looks the same. In Python, we call it that. I'm not saying that's not a term of computer science in general. That's a term of the Python language, special name. I call them ribs because to me they look like, I don't know, because they stack up and make the rib cage inside of a class, like a Python class. Like if I was building a Python, like a snake, and I wanted to have like the birth method, right, is called initialization. That's how we give birth to a snake. But then we have other things like get attr or whatever we want to have, call, and these are what I call ribs, and they're kind of making a backbone. If you think of class Python as the head, then this is going to be like the middle of the body where it's appending the food that we feed it and so forth. So this is a simple enough Python script where actually we need to start when it's born with an empty stomach. So we'll say every self of the Python type that we ever give birth to is going to always begin with an empty stomach as an empty list. And then we have this call method. Now what does that do? I'll show you. I'll create my new little Python snaky, and I don't have to pass anything in. I'm now running this initializer by saying Python open close parens. Now if you've been using Python for a long time, everything I'm telling you is something you know already very well. Look how I can just slide this, by the way. Not every IDE is, this is my favorite IDE for teaching Python right now, partly because of this easy way to slide things up and down. You can also clear the screen. You can also reset, which means empty the memory of everything. Because as soon as I run something over here on the left, I'm going to now have that available to me on the right. I'm going to be able to use the main function over and over. And every time it's running this print emoji, right? It's not running this now because I've already just created in the namespace I'm in at the top level. I've created this main for myself. Here it is. This is main. And what it does is it prints emoji out to this screen over here, which is like a whole other universe. And the length, though, the length of this list, which is called emoji, I can just talk directly. No, it's not. I have to go import Unicode. See, emoji, this isn't the reason. Okay, let me tell you something. The reason emoji is not accessible to me right now is because it was never created at the global level in my current version of the module over here. If I just do the following, if I just say emoji initialize at the top level, like now you're going to persist as a global and you're going to be inside my REPL. You're going to be over here where I can use you because I'm promoting you from being just a local variable inside a function, and I'm saying, oh no, you're at the same level as main. You're going to be remembered and persisted for all time in that role. And I'm just going to take away this print main, and I'm just going to have this return the emoji object. It's going to be a list object with the emojis inside. Now it's going to be up to me to run main on my own. So I'm going to save this. I'm going to do a hard reset over here. But before I do a hard reset, which means before I clear its memory, like erase the blackboard, let's go ahead and cut and paste this class because I think I'm going to need it. And look how nicely it takes away all this ... colon stuff. When I'm writing the class, that's helpful. That's telling me that the class is still open and in process and I'm still editing it. But then when I paste it over here, all that stuff goes away, all that punctuation I don't want, because this is the pure form of that class. So now I'm going to run it again after just erasing all my memory over on the right. So I'm just going to forget everything. I just am forgetting everything. It asks me if I'm sure I want to do that. And now I don't have main. I don't have any of this stuff. It doesn't know anything. So I'll rerun this now. So I just reran it. And now it will know main. I can say main, and there they come back. Return emoji, and it prints vertically. That's characteristic of IPython, to want to print that thing vertically. It just returned a list. Now if I feed it to print, I think it maybe won't be as vertical, or maybe it will be. Let's see. No, that looks better. And the length now of this list, so let's emoji now. I never said it was global though. Let's see. Emoji is just going to be empty now because no, it is okay. Thinking right. It's a mutable object, emoji is, and when I declare it in the global namespace, it becomes changeable, mutable. It is already mutable the minute I create it in the global namespace. And I don't have to do this. See, if you're a Python programmer, you know that there's this ability to declare something to be the global. But I don't have to do that in this case because I'm not repointing the name emoji or doing anything to change the object that it means. It already, at this point, means the global emoji, already means the same object, and there's nothing I have to do to make that happen. That would be true anyway. It's only if my code repoints it somehow to a whole different object versus mutating it. It's a different thing. When you append to a list, that's mutating the list, but you're not pointing the name of the list to a whole different object. That's a different thing. And to take control to that level, you're going to have to make sure it's declared global inside the function. But I don't have to do that. This is more advanced than we have to talk about right now. Anyway, what I wanted to just be clear on is this difference here between these two hexadecimal integers. What's kind of fun is we can declare the base as the second argument. As long as we use a string type as the leftmost argument, I can just say F, and I can say, what's that in base 16? And if you've learned your hexadecimals, which you may or may not have, depends on which track you're taking through high school. Oh, what did I do wrong? I forgot my comma between the two arguments. If you're on what I call the lambda calc track as opposed to the delta calc, and you can be on both, but from my point of view and my lingo, if you're doing lambda calc, that means computer sciencey stuff, then this makes sense to you. You understand about base 16 and so forth. Whereas if you're on the delta calc track and not taking any computer science, then Common Core kind of threw out everything but base 10. So if you grew up under Common Core, you don't know about base 16 necessarily, although a lot of teachers were kind of under the table still teaching it. Now I still do have the Python class available to myself as well, so let's do that now and then I'll quit. So Python is just been invoked. That's talking about this Python over here. I just ran the birth method, initialization method, and created an empty stomach inside this particular self, the snaky, this instance. So now I can go snaky and just call it with arguments. Why can I do this? Because, let's see, what does my snake want to eat today? Let's eat the Cookie Monster. I hope I don't get in trouble for that. Actually, that might be too controversial. Ice cream, okay? We won't eat the Cookie Monster today. And now we can check inside Snaky's stomach, and lo and behold, now this is something each self will have. So if I create a second snake, you can't write it like that. You can't start with a number. But Snaky 2, that's very unoriginal. If I create her or him, or it or them, as a second snake, now it has out of the box, you could say, an empty stomach. I can look at that directly. There are different ways you can get into the content of a specific object, an instance as we call it. You can look at its well, that was interesting. In IPython, which I'm using, I get a longer list than I may be used to from the directory. These are all the methods in any object. They all inherit from an object called object. So if I were to do a dir of the mother of all objects, it would have a lot in it. And then in addition to all that stuff, we have what's specific to the snake. So the snake is the Python is a subclass of that their object. Anyway, that's a quick introduction and a reminder of why we had 32 emoji. Because why? Because it's base 16. So when in the last video I said the first 20 emoji, I should have said first 20 base 16. See, that was what I forgot to say. But now we can do them anytime. We can look at them. And this is not all the emoji, right? It's the first 32 or first 20 base 16 emoji. And you can do things like find out what is the number associated with each one of these. That's called the ORD, O-R-D, like ordinal. Like in the order of 0 to a billion, what is the order of any one of these smiley faces? Let's feed in the first one, emoji 0, and it's 128,512 decimal, right? Now I can convert that to hexadecimal, 128512, and we'll see what that is in hex. It's 1F600, which is what we see over here on the left, is where we're starting. And if you want to go the other direction, you want to say start with the character function and feed it this number. We can feed it a decimal. Doesn't have to be hex or anything. Then we get back the smiley face. So this is going back and forth between the underlying number, which is sort of how it's encoded in the Unicode database, versus how it looks, which if you have an IDE that's capable of displaying GIFs like the, or GIFs or glyphs, I should say glyphs. Glyphs are the actual font as it appears to your eye on a piece of paper. It's not just a number anymore. It's the actual pictograph of that letter A or Hebrew character, Arabic, any kind of language is going to have its glyphs. And emoji are just more glyphs, right? So Python helps open your door into the Unicode world, which I would think is something you shouldn't wait till after high school to start learning about. Like Unicode is kind of 7th, 8th grade kind of topic this day and age. So you can calibrate on that. And we'll talk to you soon. Have a good rest of your day. And hang in there. It's going to be fun.